Greetings, everyone, and welcome to the latest episode of Velodyne Lidar Live, where we get a chance to talk to experts in every area of mobility. We're going to talk about some of the latest technology as we all experience this wonderful transformation of transportation. I'm Charlie Vogelheim, and I'll be your host today in today's conversation. If we haven't met before, if you haven't seen me, I've got decades in the auto industry. And I did a podcast for Motor Trend for a number of years, a radio show, and got involved with Velodyne through their wonderful World Safety Summit. Now, Pam will still be doing episodes going forward, but I'm going to help her out a little bit. I don't work for Velodyne, but I'm very proud to be a part of the company and what they're doing. And just a quick overview as we see the screen up. I'd love to remind everyone that it's been around since 1983. Involved with the DARPA Grand Challenge that we all refer to in this development of autonomous vehicles back in 2004, real-time 3D LiDAR in 2005, first commercial production of real-time 3D LiDAR in 2007, and today, again, a leader in LiDAR technology. We have a number of offices around the world. Mary is in the background doing our slides as always, and a big help. But as a reminder, again, located on the West Coast, where I am right now, with the offices up in Alameda, down in San Jose, and other world offices in Russelsheim, Germany, and Beijing, and in Thailand. So today's episode, I'm very excited about. We have our guest is Kat Dransfield. She's a VP of Product and Digital Platform Strategy at Local Motors. And I'm very excited to have her on today because she's got such a great background, and so does Local Motors. So reviewing what we're going to talk about today, over the next 35, 40 minutes. We introduce Kat. We're going to talk a little bit about her background. Of course, we do want to talk about Local Motors. And then Olli will introduce you to, which is one of the products that they have. And we've got a picture of Olli here. We'll learn more about what Olli's doing. And one of the reasons we're so proud to introduce him is you can see right in front there is the Velodyne Lidar. That's an important part of the sensor array for Olli in autonomous travel, and we'll learn more all about all of that. So without further ado, let's bring Kat in. And once again, everyone, thanks for joining us today. Kat, welcome to Velodyne Lidar Live.
Yeah, thanks, Charlie.
Hey, thanks for being with us. You've got such a great background. I want to spend a little bit of time with that, just some of the personalities that are involved in the technology and technology change. So if you don't mind, and I know a little bit about it, so I might ask for more details, but let's talk about your background, your studies, and how you got involved in all of this.
Yeah, sure. So I started my career as a naval officer, first briefly in the Navy nuclear submarine program. And then actually I spent the bulk of my time in the Pentagon working in the Secretary of the Navy's Emerging Technology Office. And so that was a wide array of projects, everything from AR, VR to advanced AI and machine learning to autonomous projects. And so that was where I kind of wet my feet in the autonomous world. From there,
okay, wait. I got to slow down a little bit. I mean, sure, yeah, using the term wet my feet, Navy, submarine, you're jumping ahead through all of that. And so it's an impressive conversation just to say, in terms of your background, one of the things about the technology and everything is about inclusion and gender and others. And obviously you joining the Navy and even being on a submarine had to be a very interesting experience for yourself.
Yeah, absolutely. And I think, I was part of one of the first cohorts of women to be selected to serve on, U.S. naval submarines. And I think it really informed my belief that the group of people who design and evolve our technologies have to be diverse themselves. So that was kind of my one big takeaway, was just the importance of user-centered design from having been a user who the system was not designed for. And so I think, that was something that I've taken with me throughout my entire career. And I think the other thing really was just watching, the amazing technological innovation that is furnished at the intersection between academia, government, and industry, which is kind of really motivated. Certainly my work currently with Olli and in working with, whether it's local or federal agencies, academic partners, and then obviously technology partners throughout the world to make Olli real.
Yes, no, and again, so going back through, let's just finish off your Navy career. You're involved with the Navy for how many years?
So I went to the Naval Academy and then spent 4 years after the Naval Academy in the Navy.
Okay, so first of all, again, congratulations. No easy task to get accepted to the Naval Academy. So kudos to you for that. And then again, thank you for your service after that. And again, I've been out there. I've got a good friend whose daughter is going through, and it is a challenge, the whole process. So congratulations. And it's, so I just wanted you to know that I was excited to talk to you. Almost like I could spend the whole time talking about that, but we've got so much more to go over. And then
that's a much longer webinar.
As you mentioned, you yeah. But then also your involvement, as you said, you got involved in the Pentagon.
Yeah. So
going forward after the Navy.
So yeah, my background was, or my academic background is really in how data-centric technologies and humans interact from the level of brain structure up. And so that made me a good candidate for thinking about what the Navy at the time was trying to evolve in terms of its thinking about data-centric technologies and digital strategies. So that was where my work was primarily focused in the Pentagon.
Well, I'm sure we all, understand, the technological advances of all of our armed services, and so much of it has to do with, it seems like weapons, et cetera. But obviously interaction, as you're saying, anything that has to do with the development, there has to be a competence and efficiency evolved around anything that before can be adapted and utilized by the armed services.
Yeah, absolutely. Yeah, and I think the other way around as well. I mean, so some of the most amazing technologies that we enjoy today were spun out of either DoD or DOE programs.
Right, and we even mentioned DARPA at the beginning in terms of Velodyne's involvement in that, and that's kind of the forefather event of some of the autonomous, at least in the transportation side, or that consumers might one day enjoy. So, or beginning to, as we're going to learn today. Then after that, your academic career wasn't done.
Yeah, so I went to grad school and then then did my time in the Pentagon, and then moved my career out to Silicon Valley, where I worked on hardware projects, everything from optics for augmented reality and virtual reality to large format additive, which is kind of, has been really the genesis for my work at Local Motors.
Okay, and once again, I know you're modest because you're jumping ahead. You just said my graduate work, so let's drop a name there where you did some of your graduate work.
Yeah, so I was lucky. I spent a year at Oxford in the UK as part of their Oxford Internet Institute, which is one of the newest departments at Oxford University. So really lucky to be part of an early cohort there, and just great, great faculty, great student body, and very, very appreciative of how that launched my career.
Okay, now we can get back into the travels west. So obviously, so much of the technological development, Silicon Valley on the West Coast, Velodyne we mentioned headquartered out here, and then what specifically brought you out?
In my case, it was my spouse's job, but no, I knew that I wanted to spend some time in the Valley, and I mean, the technologies that are being built in the Valley have, such wide sweeping consequences that it was something that I felt I needed to and wanted to be a part of.
Yeah. And where did you first start out here?
Yeah, so I worked at a company called Applied Materials, which is actually a semiconductor equipment firm, but I worked on their emerging technology portfolio. So all of their sort of adjacent and new market technologies.
Yeah. Well, of course, you're here to talk a little bit about it with your role at Local Motors. And so before we get into that, a little background. Local Motors, I've been excited about for many years, and I'll tell you why back in 2015, they demonstrated a 3D printed car, the first one, at SEMA, which is the aftermarket show in Las Vegas. It's a show that I would go to on behalf of Motor Trend to see all the latest and greatest that was about performance or add-ons, whether it was engines or transmissions or exhaust, so many different things to a vehicle. And there in the lobby was the extruding machine, as I call it, the carbon fiber toothpaste. That was building a car that was actually for someone to ride around in.
Yeah, we call it the Play-Doh Fun Factory. So I think Charlie, are thinking of along the same lines. But yes, yeah, that was really our big step change for the company in terms of our thinking about how we go about manufacturing the vehicles of the future and some of the affordances that we get with novel agile manufacturing techniques like 3D printing.
Well, again, that's your name. Local Motors was about the possibility that vehicles or transportation could be developed and then manufactured in the locale where they were going to be utilized. So it was going to be a kind of a bonus to the area, to the delivery of these vehicles, to creating vehicles that were specific to their use. So it was very interesting how, again, I thought Local Motors was a great example of the technology of the day as we were talking about a transformation of transportation, and they were supplying the product at the location, 3D printing coming together with so many of the other technologies. So I was fascinated by them in that regard. So let me turn it over to you, and you can give a little bit from that step in what year you joined them. But again, I visited some of the manufacturing that was going down in the greater Phoenix area.
Yeah, sure. So in terms of a little bit of background, so Local Motors was founded in 2007, really with the vision that the way we currently design automotive technology is not smart. And moreover, that the manufacturing and design techniques that we use could also be more agile, more nimble to market changes, more sensitive to end user needs. And so that journey started with the world's first crowdsourced vehicle called the Rally Fighter, which basically proved out that vehicles didn't need to be designed in a very insulated way by a small group of people within large OEMs, that you could in fact build a much better vehicle by being much more open and collaborative about how that vehicle gets built. The next step change, as you mentioned earlier, was in bringing additive into the fold. And so, yeah, as you mentioned, we 3D printed a vehicle in 44 hours on the showroom floor of IMTS. And that really became the proof point for the fact that these vehicles didn't need to be manufactured out of ABS plastic. They could be manufactured out of vehicles that have the same or better structural properties as a traditional vehicle. And oh, by the way, we could do it with a fraction of the parts that you would need in a traditional vehicle. And so that was really the proof point at sort of the prototyping stage for being able to use additive in a meaningful way to build a vehicle. And then this next phase of our growth has really been about layering smart technology on top of that core competency in additive. And a big part of that is the work we're doing with Velodyne, for example, to bring autonomy into our vehicles, and also proving out that additively manufactured vehicles could be commercialized and produced at scale. And so this next phase for us is really just about that phase of growth and going from tens of units to hundreds of units to thousands of units.
Well, I loved how a couple of things that you reminded me of is about that structure, and it was rough around the edges, to be polite, but that's okay, because again, the aspects of that were important at the time was the structure and how much could be built into the structure itself instead of having to build a frame or body on frame, that type of thing. I mentioned carbon fiber. I know you worked with laboratories to create a strong outer structure for this, and then again, reducing the number of parts overall that this vehicle could be manufactured in a way that was just necessary, and whether that was a combination of electrification and some of the other things, and just utilizing, again, this ecto frame, for lack of a better word, that could be put out there as a demonstration. And then again, you've when I see what you're building now, obviously so much more refined vehicles and confident and things like that. It was fun to be part of that starting point that was over 6 years ago. So.
Yeah, and then I mean, the next wave of this with respect to the additive component of our vehicles is actually proving out the recyclability of them. So we actually have a number of R&D projects underway where, it's looking very probable that when these vehicles reach the end of their life cycle, we can grind them down back into pellets and then pipe those pellets right back into the 3D printer, with some percentage of new pellets as well, and, preserve the structural integrity of those vehicles, but, have major recyclability in our own vehicle production.
Yeah, and another thing about local that I kind of, you had kind of there was a fun-loving attitude about everyone that worked there, that there was a degree of discovery going on, and sometimes there were some fun little vehicles that you guys had to ride around the factory floor and things like that. Again, experimenting with motion, experimenting with the 3D printer and the type of transportation that people might enjoy to be a part of. So.
Yeah, absolutely. So yeah, we definitely employ a lot of gearheads. So not me though. I'm not one of them.
Well, so I showed a picture of Olli, and there's a lot to talk about in terms of let's let you now take over and give a competent description of this vehicle that you're so proud to reveal, or I've seen it in display.
Yeah, so in this photo you can see our two generations of our Olli products. So we call them the Olli 1.0, and then the one on the right in the photo is the 2.0. And the really amazing thing about this that it excites us, and I think is just really disruptive to the market, is to be able to do a massive automotive redesign in a period of just a couple of years. I think the delta between our having our 1.0s running and then having our 2.0 model released was something like 18 months, right? When in traditional automotive you'd be looking at a timeline of between 5 and 7 years. And so just the ability to be much more sensitive to user feedback, much more sensitive to our customers' needs in terms of evolving our products, is really exciting to us, and to be able to actually enact those changes at scale fairly quickly.
Well, I want to just remind everyone that's listening that if you do have a question, that you can use the Q&A portion, and we'll get to those as time allows. We have about another half-hour conversation, and I neglected to make sure everyone knew that. Anything about that we've talked about now that we're going to talk about, again, we welcome questions in the visitor participation. As I'm looking at the picture here, and obviously I've seen it in motion before, you talk about design and such, very specific use for this vehicle. So let's talk a little bit about what you're trying to accomplish with the design.
Yeah, sure. So our target market is really the low speed shuttle market. So shared vehicles, 25 miles per hour or less operation. So where that puts us is pretty squarely in sort of the first mile, last mile zone, in addition to things like hospital campuses, university campuses, places where traffic moves fairly slowly, but there's extreme demand for efficient shared transportation.
Now, again, it's the design. I mean, for a car guy, obviously the 3-box design, your engine, compartment, and luggage or trunk space isn't necessary. So do you have a design that you like to call this? I've heard the word toaster, but I don't think that's polite.
Toaster. Yeah, I mean, I've heard people refer to it as the iPhone car. I'll probably get sued by Apple for saying that, but
we'll call it the J phone.
Yeah. But yeah, I mean, we really, sort of in the design of Olli stepped back and said, what is it that users actually need? And then, layered on top of that, just the constraints of having an electrified vehicle, obviously having to have a lot of compute in the vehicle. The vehicle has a massive amount of wiring. So we have to get, pretty creative in terms of, how we route both our high voltage and low voltage wiring Yeah, I mean, we've got some unique functionality with, instead of having a standard drivetrain in the vehicle, we actually utilize hub motors that are provided by a company called Protean, which are actually have more torque than a Ferrari. But that A, reduces road noise, and B, frees up space for some of that electrical or battery compartment compute, for example.
Well, I congratulate you. Few people use the term low-speed shuttle and Ferrari in the same.
Yeah, we've managed to do it. So,
but you know, what I noticed right away, of course, is how airy it looks. It looks very open, very light on the inside. And then, of course, I'm actually a big fan of space utilization. And again, that's another thing that struck me in terms of, look, there is a purpose for this vehicle, and we don't have to follow, specifically historic designs. It's getting people at as you said, a low speed from point A to point B, and let's make room for everyone and make them feel, that they've got good visibility and everything on the outside.
Yeah, absolutely. And then, we've also got a lot of work going on currently with the DOT and the Santa Clara VTA, actually in Silicon Valley, around just exploration of accessibility features for the vehicle. So we know that ADA was not designed with autonomous vehicles in mind. And so our work with them has been really exciting. We're working with the Palo Alto Veterans Hospital to figure out what the future regulations for ADA need to look like for autonomous vehicles through the piloting of various features and cabin redesign. So yeah,
and I'm going to ask you said VTA, make sure everyone knows what that stands for, because if you're going to use 3 letters, you got to explain them.
Oh yeah, that's right. Yeah, so that's the Valley Transportation Agency in Santa Clara County. So yeah, if you've ever gotten on a train or a bus in Santa Clara County, it was probably operated by that organization.
Right. And again, your work with the VA, I think, is remarkable, because to your point, again, utilization of something like this, and particularly in any kind of, whether it's a hospital or it's a campus that maybe is for elderly retired people, there's a lot of considerations for getting the folks on and off the vehicle.
Yeah, absolutely. And yeah, if there's anything I've developed an appreciation for, over the past couple of months, it has been just how poor of a job overall we have done in the transportation industry of accommodating people with whether it's, physical mobility challenges, cognitive challenges, and, some of the, for example, some of the comorbidities that, that go along with being elderly, right? Perhaps using a wheelchair and not being able to hear very well. And so that work has been incredibly difficult and grueling, but I think, is leading us down a path of creating a technology that is much more accessible to more people.
Okay, so we talked about the platform as electrical. Obviously, there's a concern, or there could be, around safety with an electric platform. So let's talk about that real quick, just in terms of, we'll work from the bottom up, so to speak.
So you mean in terms of safety of the electrical system, or?
Yeah, or the battery utilized, and anything that you want to talk about in that regard.
Yeah, so I think for us, like, safety is our core design principle, and we fundamentally believe that safety is not a feature that you bolt on; it is something that you design into the product. And so, certainly our battery program, there's a heavy emphasis on going through all of the certifications required for that battery to be globally certified, depending on where the vehicle is going to be located. And then, beyond that, building massive redundancy into the vehicle. I mean, today I'm proud of the fact that, we are among the only companies that, have been driving electric autonomous vehicles on the road who haven't had a single incident.
Okay. And what is the battery chemistry?
That is a good question. Off the top of my head, we're actually in the middle of a transition, so I don't want to give you the wrong lithium. All right. Lithium and.
Right. And we're not going to put you on the spot too much about that. But we at the end of this, we'll certainly have your contact information, and we'll be able to get on direct contact, or we can do some follow-up. So that's funny. I give tours at auto shows, and I always get frustrated when somebody says, "How many gallons is the tank hold?" I'm going, "Stop it." You can look that up. But so so from the bottom up, again, electrification, and now again, the design of the vehicle, like you say, it's relatively airy, working on the load unload factors for people with different challenges. It's interesting, you know, I'm thinking about mobility, I'm thinking about whether they're wheelchair, walker or something, and then you make a mention of just being able to hear or not, which wasn't something that I was thinking of originally as being a challenge in terms of getting people on board or giving them any kind of instruction in terms of the motion, et cetera.
Yeah, I mean, particularly with you know, with autonomous vehicles, they're very, and electric vehicles, they're very, very quiet. And B, you know, just in terms of, you know, sort of a visual reference, you know, if there's somebody turning a steering wheel and, you know, you can't hear, you can sort of infer what the vehicle is going to do, you know, based on that, and, you know, prepare your body for that, prepare your mind for that. But, you know, when you take the steering wheel out and you're not getting those visual cues about what the vehicle is going to do, you need to think about, you know, cultivating trust between the robot and the human in a very different way.
Yeah. So now let's talk about, you made mention of being on the road. So let's talk about where Olli has been and traveling and what kind of experience Olli has so far.
Yeah, sure. So Olli is deployed in all around the globe. We've got a bunch of deployments in Florida currently. We're in the process of launching a service in Yellowstone National Park.
Really, what part of Yellowstone would Olli be? Just around the visitor center, or?
You know, I'm actually not sure what the exact route is there, and I think there's a couple of different routes that are being programmed currently, and so yeah, I think, you know, the expectation is it'll be in, you know, some of the more high traffic areas.
Yeah, obviously, yeah. Just gonna have to make it geyser and grizzly proof.
Yeah, actually, truthfully, like one of the things that we've had conversations with the park rangers about is the buffalo. So
wow. One of the, buffalo doesn't come up a lot in autonomous vehicles.
Yeah, no, yeah.
Having driven through the park a few times.
That wasn't really an edge case we had thought about, but here we are.
And it's not an edge case there. It's straight up traffic. So when you say a bunch, though, I mean, is it do you consider the number of vehicles out there, or the number of trips, or the number of miles? What's a good measure for you in terms of monitoring success or challenge?
Yeah, so I mean, I would consider us in the you know, midst of our first major sort of commercial rollout. So you know, we've built probably on the order of about 50 Ollies so far. And so, yeah, I mean, the next step for us is really just getting mileage on those vehicles and, you know, collecting the feedback from our customers and our users, and continuing to evolve the autonomous system to, you know, to accommodate more edge cases and improving the performance of that system.
Yeah, and get a big set of horns on the front is what I think you need to go toe to toe with the buffalo.
Yeah,
I think that's how you earn respect for the buffalo.
I'll put that in our product development process.
I know you have some photo and video that let's make sure everyone gets a chance to see more about Olli, and then we can talk more about it. So if you can walk us through this.
Yeah, sure. So this is one of our deployments in Germany, in a town called Hambach, where we're currently operating a service that takes folks from the parking area of a major tourist destination. This castle that Charlie was joking earlier was my home, and yeah, so I mean, that's just one example of, you know, our use case in terms of, you know, reducing congestion, you know, obviously reducing emissions and providing, you know, safe, frictionless transportation to people who need it.
So, and not to take anything away from development, but again, to see deployment happening, relatively short distance, relatively defined route, so to speak, for Olli to go to work on over there in Germany, as you demonstrated.
Yeah, so yeah, right now we only operate on fixed routes, and, you know, within those routes we have some flexibility in terms of, you know, where we can put stops, so we can sort of do on demand within fixed circuits. You know, the hope is that eventually that's extensible to being able to provide more of an Uber type shared service where, you know, you're not necessarily on a fixed route, but you're aggregating demand around virtual stops, and But we've got to map the world first. So.
Right. Well, and I don't need to short shift the just the safety or the challenge of getting people on board and off board, before and after the trip. And then talk to me about the deployment. Are there safety drivers in place now, or is there any that are fully autonomous?
So currently by regulation, and the only exception is Germany actually just announced in the last 2 weeks that it's going to allow for certain operational domains, they're going to allow truly driverless. In most countries, we're constrained by regulation, even if we're highly confident that the vehicle could operate itself safely. And so in all of our vehicles, we have a safety attendant who's there to monitor the operation of the vehicle, who can manually take over control of the vehicle and stop the vehicle in the event that there's some type of anomalous behavior going on.
And I imagine you log whether that person had to intervene at all or not.
Yeah, so that if there is some sort of incident that requires a manual takeover of the vehicle, that's logged. It's reviewed within 24 hours by our autonomous supplier, and we either change, if it's a modeling issue, we change model weights and change how the system works, or if there's another explanation for it, then we go down that path. But
yeah, so I'm interested, and I'm also kind of paraphrasing one of the questions that we have in terms of the threshold of confidence. Obviously, to a certain point, right now it's regulatory, but then internally, it'd be interesting to how do you establish that threshold of confidence that you could have it like as you will in Germany, at what point that you can allow it to operate without the safety attendant.
Yeah, and that comes back to taking a look at our performance data, and truly, one of the struggles we have in terms of regulation right now is there are no baselines, and so right now it's really about getting the data so that we can begin to decide what those safety thresholds are. Anecdotally, what I use is the vehicle safer than me driving, right? Yeah. But that's maybe a qualitative heuristic that's helpful, but we need a lot more analytic rigor behind that for sure.
In terms of rolling it out, obviously, we're particularly Velodyne is proud that you're utilizing the LiDAR. Can you talk about the sensor array in terms of what the needs are? Because once again, even though you say low speed shuttle, fixed route, there still are challenges around that. So does that, I know that would make it quicker in terms of perhaps design elements, in terms of, you don't have high speeds or perhaps crash or rollover things, but still the autonomous feature, does that make it easier, or is it still always a challenge for anything that's moving?
Yeah, I think, when we talk about edge cases, the edge cases tend to be lower consequence, and you're giving the vehicle, by traveling at lower speeds, you're giving the vehicle more time to negotiate decisions. You're giving other drivers more time to negotiate decisions. And I firmly think, just in terms of how the autonomous market is developing and how the technology is developing, AI doesn't generalize well. And so, I think we're going to see a lot of specialization in terms of the types of autonomy or autonomous system architectures and modeling techniques that go into those different systems, right? My requirements are very different if I'm operating in a very dense urban area at less than 25 miles per hour, as opposed to, if I'm driving on a highway in Utah. I can probably do one of those things with, some ML and an optical camera. The other one, I need a very, very different sensor array, very different autonomous architecture.
So you're in constant flux in terms of what the sensor array might be in terms of where you're being utilized.
Yeah, absolutely. And the sensor space itself is evolving so quickly. So, our strategy as a company is to really, really focus on that integration layer, so that as the technology in the autonomy space evolves, we're prepared to make some of those, choices and pivots as that technology matures and becomes better and better.
Okay. And it's interesting as you were talking, and I'm just visualizing this specific utilization, and having followed all of this for so many years as it goes on, it's always interesting when I talk to somebody like you, because I get just a slightly different idea about how things are versus how they might be. And I'm thinking about how sometimes roads or transportation has some kind of assumption that that person will get out of the way, or whether it's a train whistle or a crossing gate or something, and a quiet, even though slow moving vehicle like this in an area where somebody might either have sight or vision compromised, then all of a sudden you can't make that assumption or if it's a buffalo, you can't make the assumption that it's going to get out of the way. You really have to build in the defenses or the protection in the vehicle and the operating system.
Yeah, and in developing the communication protocol with those other entities on the road, whether it's buffaloes or humans or other drivers. I mean, when we talk about this, I always encourage people to, when on their next commute to work, count the number of times they make eye contact with another driver. Now imagine that car doesn't, all of those times you made eye contact with another driver and subtly communicated something to them. Right. Now imagine that didn't happen, and what would the outcome have been? So we're heavily invested in thinking about what the user interfaces need to look like on the interior of the vehicle and also on the exterior of the vehicle, so that there's intuitive communication between these vehicles and the people in and around the vehicle.
And again, almost paraphrasing one of our questions, but I'm also excited about, when this first started happening in DARPA, and to simplify it, the car can turn left, it can turn right, it can stop, it can go. We'll all have one in a couple of years. And so we're becoming a little impatient because we all don't have a fully autonomous vehicle in our driveway. But this rollout, literally, to me, is a great utilization, low speed transport on a campus. Just talk about that might be the population base of AI for years before it's owned by or utilized by consumers.
Yeah, absolutely. And I think, there's a couple of other things that are required to really make this step change happen, which is, the way we are doing autonomy right now doesn't really make sense unless we should really be in my mind, thinking about autonomy without thinking about infrastructure doesn't really make a lot of sense, right? And we're designing autonomy for the infrastructure we have today, when in reality, if we could make step changes in infrastructure, we could make autonomy much safer. So, I think, thinking about the technology in that space and how we evolve the business models around infrastructure is going to be, also something that, we're going to have to invest in heavily over the next couple of years to really make this a reality.
Okay. I was thinking about other sensors in the sensor suite, and a couple of folks have been asking about computer vision. If you can comment on that.
Yeah, sure. So we're actually piloting with SCVTA right now an edge device that we deploy models on that does monitoring for mobility devices, utilizing the vehicle's optical camera. So if someone approaches the vehicle and wants to board, and they're using either a wheelchair or a walker or a scooter, the models will detect that. And then, the vision is the next step is that the vehicle would automatically deploy the vehicle's robotic wheelchair ramp. And so we're in the processes of testing the efficacy of those models right now. But the really cool thing about that to me is if it works for detecting mobility devices, it has extensibility in all sorts of other applications. So making sure, for example, that everybody in the vehicle is seated before, we allow the signal to be sent over CAN that, we can apply torque to the wheels, making sure that everybody's having a seatbelt, has a seatbelt on, monitoring the cabin for medical emergencies. There's been tremendous work done in terms of computer vision, in terms of being able to predict seizures before they happen. Imagine the ability to do that and to, remotely notify emergency responders, safely pull the vehicle off the road. So yeah, really excited about our work in that space. And, that's another space that's it's evolving so quickly.
I got ahead of some of the performance questions I had on Olli in terms of size and shape and how many people or how much load it carries. If you can do a quick review on that, it'd be helpful.
Yeah, so currently right now we carry 8 people plus the safety attendant in the vehicle. And when, thinking about size, we actually don't really squarely fit into a vehicle classification. And the reason we've landed on that size is that keeps us below the weight constraints for most residential roads, which allows us to really operationalize that model where, we can be operating in residential neighborhoods, retirement communities, those types of things. For example, places where the roads just aren't rated for the loading of a traditional, public transport diesel bus.
It's so interesting. Again, the word regulation comes up almost too many times.
Oh, yes.
And when you start talking about, load factor on the road, it makes perfect sense when you say it, but it may not be something you think about until you get into the aspects of actually designing the vehicles. So we have just a couple more questions. And I know that there's some folks that have been doing Q&A. I've been trying to paraphrase a lot of that. In terms of, and we're going to share your contact information at the end. When you look forward, again, just in a conversation like this, is there something that you're hoping, a message or something that you're hoping that I asked you about that I may not have, or that you want to talk about with Olli?
No, I don't. Yeah, I don't think so. I mean, we're really excited to be on this show today and get to share a little bit about Olli.
Yeah, no, I appreciate that. And again, I have seen it in motion, and I'm looking forward to, again, as you talk about even the aspect of acceleration or not, again, whether you anticipate it. And we've all been on public transportation, and some starts out slow or fast. But again, it's your top speed is not that remarkable purposefully. That you can go forward, and again, it's interesting in terms of who you might be servicing, whether they're really in a hurry or not to get from point A to point B, or just thankful that they get the opportunity to retain mobility at a time in their lives or in their health that they wouldn't otherwise be able to do that.
Yeah, I mean, absolutely. I mean, just to throw out some statistics. I mean, most transportation agencies take a 700% loss on every single paratransit trip that they make. So, on the cost manager side, we're hoping obviously to solve those problems there. But then on the end user side, I mean, if you're a paratransit system user and you want to go to the grocery store, you have to book that trip a day before, and you're typically given a 4-hour window where you have to wait, where you don't know when your vehicle is coming to pick you up. I mean, for most of us, I mean, we couldn't even, could you imagine losing for a 20-minute grocery store trip, losing 8 hours of your productivity that day? I mean, that is unreal. It's
not true mobility in that sense.
Not at all.
Hey, finishing off in local motors, again, we talked about, the idea of the microfactories or what is going forward? We have Olli going on. Is microfactory still a part of the future, and how complicated are the business model around establishing those in other countries, other parts of the world?
Yeah. So, our next real growth phase is definitely focused on scaling Olli into the hundreds and thousands produced per year. Our microfactory is still located in Knoxville, and I think we've seen tremendous advantages of having a much smaller footprint factory, and also to the point you made earlier about producing locally. Having been through COVID now, I think we have suffered much less at the hands of supply chain issues than traditional automotive manufacturers have, because we do try to source locally. We obviously we print the vehicle structures ourselves. We're not reliant on what's going on in other countries for the fabrication of some of our major components, and we can make our own tooling. I mean, that's the other thing. I mean, 70%, I believe it's 70% of our vehicle by volume is 3D printed, but that it doesn't include, all of the tooling we create for the fabrication of other parts. So that is absolutely, absolutely still at the core of who we are. And, as we expand globally and start to see market traction in other places, the hope is that the microfactory model, continues to expand into other geographies.
Is there a range? I mean, approximately what does it cost? What does it take to invest in one to get one up and going? Or you have off-the-shelf microfactories or
off-the-shelf microfactories? No, I think is the answer to that. Yeah.
But if somebody was interested, how would they find out more than just contact you directly? Or
yeah. I mean, I would say, reach out to me directly, and we can certainly, within the confines of not sharing anything too sensitive, we can talk about it more.
Right. Well, I appreciate it. I mean, our conversation today, it seems like we've been able to cover a lot of stuff. I still want to know a little bit more about the nuclear submarine operation, but and then again, just that the whole concept of what you go through in all of that. Really appreciate learning more about you, Kat. And then again, the work that you're doing. And if there's anything else you'd like to add on other developments at Local Motors, now's your time.
No, thanks for having me on today.
Well, we really appreciate it. Thanks for taking the time. And once again, here's some contact information. You can get a hold of me at the webinars at Velodyne.com. Contact Velodyne if you want further information about Kat and what she's doing, or directly, you can see the Kay Dransfield at local-motors.com. And we really appreciate your time today. And thanks for sharing us with here at Velodyne Lidar Live. So look forward to seeing you out and about, Kat. And thank all of you for spending your time with us. And hopefully you got something out of this conversation. We'd love to hear from you. If there's anything that you'd like us to cover that we didn't, please let us know. I want to remind everyone, I'll be back again next month. Be talking to May Mobility, and we'll look forward to that conversation in July, on July 9th, 10 o'clock regular time when we broadcast, or as all of these episodes are available on YouTube afterwards. So I'll say goodbye. Thank you very much. Have a great summer beginning, and we'll look forward to seeing you again soon. Bye all.